Hello. Today I want to do a screencast on how you can create a simple C-based project with Autotools. Sometimes this can seem rather daunting and the material online is a bit overwhelming for something simple if you want to just something to start with. Copying and pasting the Autotools configuration files from other projects can create configurations that are a bit too complicated to understand for the beginner. So I kind of like to start simple and start from scratch. And fortunately, there's a rather simple way to do that. So the first thing I do is I create a project directory, and I'm going to call this first GTK. This will eventually be a little GTK program. And then inside that, we're going to create several subdirectories. I like one for my source code, one for my tests, one for my builds, and then we make a M4 directory. This will get used by Autotools. That is the new paradigm now to put M4 macros inside that. You don't need to know about that now, so don't worry about it. And then inside the source directory, we're going to create a little hello world program. So main call include stdio int main int argc char star argv oops and puts hello world and return. Okay, there we go. And we'll just make sure that compiles cleanly, which it does. So that's kind of our structure to start. Let's take a look at it graphically here. We have a directory called first GTK, which is our project directory. In that we have several subdirectories: build, M4, source, and test. Currently we only have in the source directory a main.c file. The object file, we don't need that. That was just to make sure we compiled cleanly. And that's where we start. So the next thing that I do is I create an automake file. Automake file is created in the root of your project, in this case our first GTK folder, right? And we go makefile.am for automake. And the only thing that, there's just a couple lines that we need to start this with. One is the bin programs command or directive, and this names the executables that are going to be created and put into the bin directory, usually user bin, upon make install when you install your application. And we're going to call this first GTK, same as our project. And then the next one is we're going to identify the source files for this project. So first GTK, which is the name of our executable right here, right? So that starts with that, and then underscore all caps sources. And here we delineate all the source files that relate or are required to compile that program. And to start, we're just going to use our main.c file. Now, notice that I did this backslash here. This file is intended to be a one line, and in order to extend it across multiple lines, you have to escape the new line, and we do that by hitting the backslash immediately followed by a new line or the enter key. That way we can do multiple files like this. Also, as we add files to this, our headers will go here as well. So for instance, other.each. The last line does not need to have an escape to new line. So for now, all we need is that right there. Okay? So we've defined what our executable is going to be, and we've defined what the source files are going to be. Alright. From here, we can actually create the configure AC template. And that's a utility is provided for us to do that called Autoscan. So we type Autoscan and run that. This creates two files. One is a log file, which, as you can see, is empty here. If there are errors or other pertinent information, it'll be printed there, but we don't need that for now. And then the other is this configure.scan. this is our template. If we take a look at that, we'll see various generic information is put here. And this is precisely why I like to use this, because I don't remember all these little things. This is a good starting spot, and this is the minimum essentially required to create a little Autotools program. The thing is that configure.scan isn't the proper name. We need to change that to configure.ac. So we'll go ahead and do that. Configure.scan to configure.ac. So we need to make some customizations to that. So let's do that. Get rid of a couple lines here, and we're going to name this first GTK. And we'll give it a little version number. This is all arbitrary information. I'm not going to do any bug reports. And then finally, to use autoconfig with, or autoconf with automake, you need to tell autoconf that you're going to do that. And the way to do that is to add a line here called am for automake init, automake, and a couple parameters here. We're going to enable all warnings, and we want warnings to be errors. Now notice that looks very similar to compiler switches, but in fact they have nothing. This has nothing to do with the compiler. This is for automake itself. So it will enable all warnings for automake, and if automake generates any warnings, they will in fact be upgraded to errors, if you will. And the final little command we give here, or directive, is foreign. And foreign will set this project to be a foreign project, at least as from the perspective of the GNU people. In a GNU project, you need certain files that you have to have as part of your project, like a README file. And by using foreign, we make it so that that won't generate a warning or an error. And that's all we need to integrate automake with this. So here we go. We take a look again. We have our structure here, one source file called main.c. We have a configure.ac, which was generated by Autoscan. We tweaked it a little bit with the name of our project and integrated automake with this line. And we created a little automake file which defined our executable name and the sources required to generate that executable. Okay. Now, anytime you modify or create the configure.ac, and with certain modifications, sometimes of the makefile am, you have to reconfigure the autoconf system. And fortunately, there's a simple command to do that. It's called auto reconf. So, auto reconfigure, if you will, the autoconf system. And I like to add the verbose switch and the I switch. And the I switch, if we look here, actually, if we look at the mana page, the I switch says install copy missing auxiliary files. And these auxiliary files are used by the Autotools to perform things like install files and supplementary files for compilation and stuff. So you want that to happen, and it never hurts to essentially always use those switches every time, -v, -i, or just -vi. Now there's an interesting thing here. We have an error, or warning, from automake. Warnings are treated as errors, and our warning is that source main.c is in a subdirectory, but option subdir objects is disabled. Now, in a future version of automake, subdir objects is going to be enabled by default, but for backwards compatibility reasons, this is currently disabled. In the old days, traditionally, every directory had its own automake configure system set up for it, and you had something called recursive make and all this. Some people believe that's not the best way to do it, and it's no longer really required now. The only downside is you have to specify your files with a full relative path, if you will. So instead of just main.c, it's source/main.c. This allows us to easily do out-of-tree builds, which I believe to be an important feature, and I'll show you more about that. Anyway, how do we get rid of this warning? Well, we have to enable this option, subdir objects. The way we do that is we edit our makefile.am, and we add here automake options, subdir objects. That's it. And like I said, at some point we won't even need to do that. That'll be just a default setting for automake, hopefully. So let's rerun our auto reconf. -vi. And let's see what we got. Okay, so it doesn't look like we have errors, but with this interesting statement here, unescaped left brace and regex is deprecated. What is this? Well, turns out this actually isn't an autoconf or automake error. This is a warning from Perl. Perl is used apparently by autoconf or automake for some of its processing, and more recent versions of Perl have decided that an unescaped left brace like this is deprecated, and in the future may actually turn into an error. I imagine this is due to some parsing ambiguities on the part of Perl. In any case, this is a benign warning from Perl, and in a future version of automake, I imagine this particular one that you see is at line 3936, this will be fixed and will go away. So for now, if you see this particular kind of warning or statement can be safely ignored. So that means that our auto reconf has been successful. So what does auto reconf do? Well, the primary thing that it does for us that we're concerned about immediately is it creates this configure. And if you've ever installed anything from downloaded software from the internet, a common paradigm is to run configure and then make install. Well, as you can see, this configure program is rather large, 145K. In fact, if we look at it, you'll see that it's quite large here. Many lines. I mean, I don't know how many lines this is. Thousands, nearly 5,000. And this used to be written by hand, or largely by hand in the old days. The whole point of Autotools largely is to automate that process for systems so that we don't have to do that, and that's great. That's wonderful. We don't want to have to worry about that. Also, it created some supplementary or auxiliary files. They call it the step conf, install, sh, missing, compile, ac local, etc. And we don't need to be concerned about those, but the Autotools will use them as it sees fit. So once configure is made, or once we have a successful auto reconf, we can actually go into our build directory, and now we can run configure. The important point here is that I'm running configure from the build directory. I'm not in the project directory directly. The reason is I don't like to pollute the project directory with all the build stuff. There's enough stuff in there already. I don't want to pollute it with what amount to temporarily or automatically generated files. So I do that in a build directory. It doesn't have to be a subdirectory. I have the subdirectory here, but it could just as easily been a directory at the same level. I could have had some other build directory here. And in fact, some IDEs will do their builds in this fashion. The point is that not doing it directly here, but in some other directory, be it a subdirectory or outside the structure, has useful benefits that you should adhere to. So we're going to run configure now, and since the configure is in the parent directory, I need to give it the double dot, type configure, and there we go. So what configure does is it makes a makefile. I mean, it does other things, but the primary thing that we're concerned about is it does this right here. It makes this makefile. And if we look at that makefile, we'll see that, again, it's another rather large file. again, this used to have to be made by hand, and for such a simple project, we could make a very simple makefile that doesn't have all these features. But what's nice here is that this will operate on many different types of Unixy systems, even Windows, and we didn't have to write any of this, and that's a wonderful thing. This is also auto-generated, and we can make simple changes to makefile.am, and it will automatically generate all of this stuff for us. Well, okay, we have a makefile. What can we do with it? Well, the primary thing we do with it is type make. That will compile and create our executable. And now we see it right there, first.gtk, and we can run that. And there we go. We have our hello world. The nice thing about a make or any dependency build system is that if you make changes to a file, only the files that depend on it need to be recompiled. It keeps track of all that. That's what a make file was originally for, and all build systems by and large do this, including Visual Studio CMake, which is becoming probably the most popular in the Unix space. So an example of that would be if I edit or modify our source file, which is source main.c, and let's just make a change here. So let's add another statement. And let's say, wasn't this fun? Save that, and now all I need to do here is type make again, and it knows that the C file changed, which means it needs to recompile the executable. And in fact, it recompiled it, and if we run it, first GTK, we'll see now we also have the wasn't this fun line. Alright, just a quick recap. In order to create a basic Autotools project, you create a project directory, you can make some supplementary files, source, test, build, create a source file, start simple, create an automake.am file, and in that you only need to mention your executable name and the source file you created. Once you've done that, go to the root of your structure and type in autorecall -vi. It'll generate a configure script. From there, you can go into your build directory, run that configure script. That will generate your make file, and then you can type make. And that's all there is to it. You do get other things like make clean, make install, etc. I hope this was helpful. The next screencast will talk about how we actually integrate GTK with our Autotools build system.